Right now, as you sit there, your water heater is losing heat. Not because something is broken, not because it is old, because hot water rises, that is it. Hot water rises through your pipes, cools off inside your walls, sinks back down, and pulls more hot water up behind it. A silent loop, 24 hours a day, 7 days a week. The Department of Energy documented this problem decades ago. They call it Thermosyphon convection. And the fix costs under $10, a pair of simple fittings, brass or plastic, threaded right onto your water heater. Manufacturers started installing them at the factory. Then your plumber showed up and took them out. No law says he cannot. And that invisible loop has been bleeding heat from your tank ever since. We are talking $100 to $200 a year. Gone. Through your walls, into your basement air, and nobody told you, because nobody makes money telling you. By the end of this video, you will know exactly what Thermosyphon convection is. You will know how to check whether your heat traps are missing. You will know how to install replacements in under an hour for about $25. And you will understand why the entire chain of professionals between you and this fix never mentioned it. Welcome. This channel exists for one reason. The knowledge to maintain your own home, protect your own budget, and prepare your own systems already exists. It is published. It is documented. It is sitting in government databases and engineering manuals and trade journals that nobody hands to homeowners. We find it. We verify it. We hand it to you. If that sounds like something worth showing up for, subscribe. Not because I need the numbers, because the algorithm buries channels like this unless you tell it not to. Join a community that would rather know than trust. This problem has been documented for over a century. Here's the timeline. Hot water rises and cold water sinks. That is not controversial. That is not a theory. That is thermodynamics, so basic it was published in engineering literature in the late 19th century. The physics have never been in dispute. What changed was that someone finally asked what this meant for a tank of hot water sitting in a basement connected to open pipes. The answer came in the 1970s. The energy crisis forced the United States government to look at every source of wasted fuel in a residential building. The Department of Energy funded studies specifically on standby heat loss in storage water heaters. What they found was that a conventional tank water heater with standard pipe connections loses heat continuously through thermosyphon convection. The hot water port on top of the tank connects to a vertical pipe. Hot water is less dense than cold water, so it rises into that pipe even when no faucet is open. As it rises and cools inside the pipe and the surrounding wall cavity, it becomes denser. It sinks back down. Meanwhile, cooler water from the cold inlet pipe gets drawn upward toward the tank to replace what left. You get a slow, continuous loop of circulation. No pump, no moving parts. Just gravity and temperature differential doing what physics demands. The Department of Energy did not just document the problem. They pushed for a fix. The Energy Policy Act of 1992 established new efficiency standards for residential water heaters. Manufacturers responded. Through the 1990s and into the 2000s, factory-installed heat trap nipples became standard on nearly every residential tank water heater sold in the United States. These are simple devices. A short brass or plastic nipple, usually 3/4 inch threaded, 6 to 8 inches long, with a small ball or flapper inside. When you draw hot water normally, the ball or flapper lifts and lets water flow. When you stop, gravity closes it. That is the entire mechanism. It blocks the thermosyphon loop. The Department of Energy recognized it. Manufacturers complied with it. It ships from the factory on your water heater. Then a plumber installs your water heater. And here is where the timeline fractures. Plumbers often remove the factory-installed heat trap nipples and replace them with standard brass nipples. Why? Because the ball-type heat traps can make a ticking or tapping noise when water flows through them. Homeowners hear the noise. They call the plumber back. That is a free service call on a job that already has a thin margin, so the trade adapted. Many installers learned to pull the heat traps preemptively. No noise complaint, no callback, no lost time. And no plumbing code in the country requires them to leave heat traps in place. The manufacturer put them in, the installer took them out, and your energy bill went up by $100 to $200 a year. Nobody violated a single regulation. Nobody committed fraud. The system simply has a gap wide enough to drive a truck through, and you are the one paying for the fuel. What I just showed you is the surface. Inside the vault, I go deeper on topics exactly like this. Exposed building science failures that cost homeowners real money. Off-grid energy systems the utility model cannot compete with. Water treatment methods that bypass commercial filtration monopolies. Maintenance schedules the trades do not volunteer because callbacks are profit centers. No fluff, no filler. Just documented research you can act on. The link is in the description. But stay here, because what comes next is the part most people never see. Now let me show you the physics, because once you see it, you cannot unsee it. Your water heater sits in a basement or a garage or a utility closet. The tank holds water at 120 to 140 degrees Fahrenheit. That is typical. That hot water is less dense than the cooler water surrounding the pipes in your walls and ceilings. The hot outlet port on top of the tank connects to a vertical riser pipe. That pipe runs up and often across to serve your fixtures. When no faucet is open, the water in that pipe is still hot. It is still less dense than the water around it, so it rises, slowly, silently. As it moves upward and away from the tank, it loses heat through the pipe walls. The farther it travels, the cooler it gets. The cooler it gets, the denser it becomes. Eventually it sinks, and that sinking pulls fresh hot water out of the tank behind it. This is not theoretical. This is measurable. The Department of Energy tests water heaters for standby loss using a protocol that specifically accounts for thermosyphon convection. The uniform energy factor rating you see on that yellow Energy Guide sticker includes standby loss as a component. The DOE found that in worst case conditions, a tank water heater in a cold basement with long vertical risers and no heat traps can lose enough heat through convection alone to add $100 to $200 to annual energy costs. That is not electricity being used to run a device. That is heat silently leaving your tank, entering your pipes, radiating through your walls, and forcing your burner or element to cycle on again to reheat water nobody asked for. The fix is mechanical. A heat trap nipple contains either a small plastic ball that rests in a seat by gravity or a small flapper that closes under its own weight. When you open a faucet and water flows, the pressure lifts the ball or flapper. Water passes through normally. When you close the faucet, the ball or flapper drops back into the seat. The thermosyphon loop is broken. No upward convection through the hot port. No downward draw through the cold port. The heat stays in the tank. Now here is something most people do not realize. If you have a recirculation system, the same principle applies in a different way. Recirculation pumps are designed to keep hot water available instantly at distant fixtures. But if the check valve in that system fails or was never installed, you get reverse thermosyphon flow through the return line. The trade literature documented this in the late 1990s. A failed check valve in a recirculation loop can waste as much energy as having no heat traps at all. So if you have a recirculation pump under a sink or near your water heater, check that valve. It is the same physics. Same problem, same cheap fix. So why does no one sell you this fix? Why is there no marketing campaign? Why does your plumber not mention it? Follow the money. A water heater installation is a flat rate job. The plumber quotes you $400 to $800. That covers the unit, the labor, the fittings, and the drive time. Every minute on that job is a minute not spent on the next job. Installing heat trap nipples adds time. Explaining them adds time. And the part itself costs under $10. There's no profit in it. There's no upsell. There's no recurring revenue. A plumber who installs heat traps earns nothing extra and risks a noise callback. Now look at the inspector. Plumbing inspectors check for code compliance, proper venting, correct gas connections, seismic strapping where required. No plumbing code in the United States mandates heat trap installation or retention during a water heater replacement, so the inspector has no checkbox for it. It is invisible to the enforcement system. Now look at the utility. Your gas or electric utility sells you energy. When your water heater loses heat through thermosyphon convection, you use more energy. Your bill goes up. The utility has zero financial incentive to tell you about a $10 part that reduces your consumption. They are not suppressing anything. They simply have no reason to promote it. Now look at the homeowner. You. There's no meter on your hot water pipe that tells you heat is escaping. There's no gauge on your tank that shows convective loss. There's no line item on your bill that says thermosyphon waste. The loss is invisible. You cannot see it, you cannot feel it, you cannot measure it without specialized equipment, so you never ask about it. The only entity that actually installs heat traps is the manufacturer, because the DOE requires it. And the only entities that spec heat traps in their buildings are the ones paying the energy bill at institutional scale. The General Services Administration specs heat traps in federal buildings. The Department of Defense specs them in military housing. Facilities managers in large buildings know that cumulative thermosyphon losses across dozens or hundreds of water heaters hit operating budgets hard enough to notice, so they require the fix. But in your house, where the loss is $80 to $200 buried inside a $1,000 annual water heating bill, nobody notices, nobody complains, nobody fixes it. A $10 part, a 20 to 1 annual return at the upper bound. And the only person who benefits from installing it is the only person who was never told it exists. If you are still watching, you already know more about your water heater than most plumbers will ever volunteer. That is what this channel does. If you want more of it, subscribe. The next video goes deeper into the same category of institutional gaps. Now, before I give you the step-by-step, I owe you the honest limitations. I'm not going to oversell this. Heat trap nipples are not magic. Your actual savings depend on several variables. If your water heater is inside a heated living space, the thermosyphon loss is lower because the ambient temperature difference is smaller. If your pipe runs are short and horizontal, convection has less driving force. If you have already insulated your pipes within the first 6 feet of the tank, you have reduced the loss somewhat. If your tank temperature is set at the lower end, around 120 degrees Fahrenheit, the density differential is smaller. The $200 figure is an upper bound, not a guarantee. It applies to worst-case geometry: cold basement, long vertical risers, no insulation, high tank temperature. Your savings might be $50. They might be $150. They will not be zero if you currently have no heat traps and uninsulated pipes. There's also the noise issue. Ball-type heat trap nipples can produce a ticking or tapping sound when water flows. It is the ball bouncing in its seat. Some people never notice it. Some people find it irritating. Flapper-type traps are quieter, but can be slightly more prone to mineral deposit buildup in hard water areas. If you have very hard water, check your traps every few years and clean or replace them. And heat traps are one part of a standby loss strategy, not the whole strategy. Tank insulation blankets, flue dampers on gas units, and pipe insulation on the first 6 feet of both hot and cold lines all reduce standby loss. Heat traps handle the convective component. The other measures handle conductive and radiant loss. Do all of them. Finally, in rare cases with very low water pressure, ball-type traps can cause a slight flow restriction. If you have known low-pressure issues, consider flapper type or consult a pressure gauge reading before and after installation. That is the honest picture. Now here is exactly how to check yours and fix it today. Step 1. Locate your water heater. Find the 2 pipes on top. One is the hot outlet. One is the cold inlet. They are usually marked. If not, the hot line connects to the left side when facing the front of most tanks. Confirm by running a hot faucet briefly and feeling which pipe gets warm first. Step 2. Look at the fittings where the pipes connect to the tank. If you see short brass or plastic nipples with a directional arrow molded or stamped into them, you already have heat traps. The arrow on the hot side should point away from the tank. The arrow on the cold side should point toward the tank. If the arrows are correct, you are set. Move to step 7. Step 3. If you see standard brass nipples with no directional markings or no nipples at all, just straight pipe connections, your heat traps are missing. Purchase a matched pair of heat trap nipples. They are sold in pairs at any hardware store. 3/4 inch threaded, under $10 for the pair. Buy a roll of Teflon thread tape and 6 feet of foam pipe insulation if you do not already have it. Total materials cost, under $25. Step 4. Turn off the fuel source. For gas, turn the gas valve to the off position. For electric, switch off the breaker serving the water heater. Confirm it is off. Step 5. Close the cold water supply valve above or near the tank. Open a hot faucet somewhere in the house to relieve pressure. Attach a garden hose to the drain valve at the bottom of the tank and drain 2 to 3 gallons. You do not need to empty the tank, just enough to drop the water level below the top fittings. Close the drain valve when done. Step 6. Use a pipe wrench to remove the existing nipples or disconnect the pipes from the tank ports. Wrap the threads of your new heat trap nipples with Teflon tape, 4 to 5 wraps clockwise. Thread the hot side nipple into the hot port with the arrow pointing away from the tank. Thread the cold side nipple into the cold port with the arrow pointing toward the tank. Hand tighten, then snug with the wrench. Do not over tighten. Reconnect your pipes to the nipples. Step 7. If you have a recirculation system, locate the check valve on the return line. Verify it is present and functional. If it is missing, install one. A brass swing check valve costs under $15. Same principle. Stops reverse thermosyphon flow in the recirculation loop. Step 8. Open the cold water supply valve. Leave the hot faucet open until water flows steadily with no air sputtering. Close the faucet. Inspect every connection for leaks. Tighten if needed. Turn the fuel source back on. For gas, relight the pilot if necessary. For electric, switch the breaker on. Wrap the first 6 feet of both the hot and cold pipes with foam pipe insulation. Secure with tape or cable ties. If your water heater is near a gas line, keep insulation material clear of the flue and any gas connections. 30 minutes, $25. And a problem that has been costing you money every single day, you have owned that water heater. Solved. The knowledge existed. The Department of Energy documented thermosyphon convection in the 1970s. The fix existed. Manufacturers started factory installing heat traps in the 1990s. The standards existed. The Energy Policy Act of 1992 set the efficiency floor. The devices exist right now on the shelf at your hardware store, under $10. The savings are real. $100 to $200 a year in worst-case conditions. Even in moderate conditions, The payback period on a $25 investment is measured in weeks, not years, weeks. And the only missing piece was someone telling you. Your manufacturer did their part. The DOE did their part. Your plumber optimized for their business. Your inspector followed a code that does not cover it. Your utility billed you for the loss, and you paid it every month for years. If you're thinking about resilience, about preparedness, about what happens when energy gets expensive or scarce, this matters even more. In a fuel-constrained scenario, every BTU you keep inside that tank is a BTU you do not have to replace. A $10 part becomes a force multiplier. Off-grid communities have known this for decades. Preppers who run propane or solar water heating systems install heat traps as standard practice, because when fuel is finite, waste is not an inconvenience. It is a threat. Share this video with someone who owns a water heater. That is most people you know. The system will not fix this gap. The code will not change. The plumber will not volunteer it. The utility will not remind you. This information moves person to person, or it does not move at all. Next week, we are going inside another gap just like this one. Another place where the knowledge exists, the fix is cheap, and nobody in the chain has a reason to hand it to you. Until then, check your pipes.